Hey guys, today we're going to talk about binomial experiments and binomial probability. And this is a special formula that works if and only if these three conditions apply. So there has to be only two possible outcomes, so either yes or no. One of them has probability p, and therefore the other one would be 1 minus p, right? Because the probabilities have to add to 1. There's a fixed number of trials, and the trials have to be independent, and the probability of each trial must be the same. All right, so if you have those three conditions, this is the binomial probability formula. And let's talk about what all this means. So if you are doing n trials and you want k successes, it's going to be n choose k. And then I don't know if you guys are familiar with this form of just being n choose k. It's the same thing. And then we take the individual probabilities. We take the probability of a success and raise it to the k power, because that's how many successes we want. And then we take the probability of a non-success and raise it to the remaining power, n minus k. So I think it's pretty intuitive, this formula, but let's see how it works. So example 1. Dwight is taking a 10-question multiple choice test. Every question has 4 answers. He guesses on each question. What is the probability that he gets exactly 7 correct? So this does satisfy these conditions because it's either right or wrong. There is 10 trials and they're all independent, and the probability of getting each guessing it correctly is the same. All right, so let's see if we could just find what everything is and then plug it into the formula. So for this one, the 10 would be the n. There's n trials. The 7 would be the k, because that's the number of successes. And then, let's see, if he has 4 choices, that means that the probability of getting one right is 1/4, and the probability of getting one wrong is 3/4. All right, so then, yeah, really easy, just plug everything in. So the probability of guessing 7 correct out of 10 is n choose k. So that'll be 10 choose 7 times p, which is 1/4 or 0.25, whatever, to the k power, so 7, times 1 minus 1/4, which is 3/4, to the n minus k power. 10 minus 7 is 3. And then we just type that in the calculator. All right, so we'll do 10 choose 7 times 1/4 to the 7th times 3/4 to the 3rd. And that is about 0.00309. Or you guys could hit math fraction and, oh, well, sometimes they can convert it to a fraction, but we'll just leave it like that. All right, example 2. So same story. Luis Gonzalez has a batting average of 0.300. Find the probability that he will get at least 2 hits in the next 5 at-bats. All right, so let's see if we could figure out what's what here. 5 is the number of trials, so that's n. And he wants to get at least 2. Okay, so this one's a little bit different. If he wants to get at least 2 hits, that means he wants either 2, 3, 4, or 5. All right, and then his batting average is 0.3. That would be the p. And then 1 minus p would just be 0.7, right? So because we have a bunch of different possibilities, we would have to find the probability of each one and then add them all together. Okay, but do you guys really want to do this 4 times? It's kind of a pain. So there is a little bit of a shortcut. Not much, but a little bit here. We could find the probability of getting no hits or one hit, and then just take the complement of that, 1 minus it, to get the probability of the 2, 3, 4, or 5. So if what you want ends up being a lot of numbers, sometimes it's better to do what it's not and then just subtract that probability from 1. All right, so I'm going to go this route here. I'm going to find the probability of 0 successes and 1 success and then subtract it out. All right, so the probability of getting 0 successes, it would be 5 choose 0 times 0.3 to the 0 times 0.7 to the 5. All right, so again, where that comes from, it's n choose k. The probability of k to the k power times the probability of not k to the n minus k power. All right, so let's see what this one is. Actually, let's just calculate it later. Then let's find the probability of 1 success, 1 hit. Well, that would be 5 choose 1 times 0.3 to the 1 times 0.7 to the 4. All right, so we're going to find both of those, and we're going to add them together. All right, so we got 5 choose 0 times 0.3 to the 0 times 0.7 to the 5th. All right, so that one's about 0.16807. And then we're going to add it to this one. 5 choose 1 times 0.3 to the 1 times 0.7 to the 4th. And that's 0.36015. All right, well, we want to find the sum of those. And that's 0.52822. But remember, that's the probability of getting 0 hits or 1 hit. We want 2, 3, 4, or 5. So if we do 1 minus that, the complement, we'll get our answer. 1 minus that is 0.47178. That's the answer. Now, you would have got the same answer by doing probability of 2 plus 3 plus 4 plus 5. All right, moving on to example 3. All right, example 3. If a thumbtack is dropped, the probability of it landing up is 0.4, so that's P. If 12 tacks are dropped, that's N. Find the probability that at most 2 thumbtacks are popping up. So what does at most 2 really mean? At most 2 means either you want 0, 1, or 2 thumbtacks popping up. All right, so we're going to have to do this 3 times. I'm not going to use the complement because we're doing it 12 times. I don't think finding 3 through 12 is any quicker than 0, 1, and 2. So let's just do those. All right, so the probability of 0 thumbtacks popping up would be n choose k, so 12 choose 0, times the probability of a success, which is 0.4 to the 0, times the probability of an unsuccess, which is 0.6 to the 12. All right, and then here's the probability of 1 thumbtack pointing up, 1 success. That would be 12 choose 1 times 0.4 to the 1 times 0.6 to the 11. And then the probability of 2 successes would be 12 choose 2 times 0.4 to the 2 times 0.6 to the 10. It's a real nice little pattern here. All right, we're going to find all those and add them all together. And then since we're not doing the complement this time, that will just be our answer. All right, so we've got 12 choose 0 times 0.4 to the 0. Why do I keep typing that in? Times 0.6 to the 12. So that one is 0.00218. All right, next one. It's going to be 12, choose 1, times 0.4 to the 1, times 0.6 to the 11. That's 0.01741. And then 12, choose 2. This is the worst part, just typing it in. Times 0.4 squared times 0.6 to the 10. And that is 0.06385. All right, we'll add those up and we are done. So we're going to add this one and we're going to add this one. And I got 0.08344. That's the probability of getting at most 2 thumbtacks side up. All right, thanks for watching the binomial probability problems.